Okay, guys, kicking off the stream again. There was some issue. Apparently, OBS was causing the slowdowns. I've restarted my computer. I've deinstalled it again and installed it again. Apparently, the settings are still memorized, so I didn't delete it completely, but restarting the system seems to have done the trick. Let's go back. Okay, let's go back to where we stopped, and that was right here. Go to train, hit run. If you have any slowdowns, let me know. Let's turn on my Discord. Okay. We are here. Let's see, we were here trying to understand what ID is. Oh my god, this is now so faster, thanks god. So we had the IDs and then we sorted the source length. And then finally, we use the same sort order to sort target lengths. Okay. And we saw that number of tokens is actually just number of target tokens, apparently. So number of tokens, number of samples is going to be equal to, okay, the number of samples, that makes sense. And number of tokens, let's just see again here. Target length, sum, and then item. So we sum up the lengths for the target. So it's kind of misleading. Why not count in both the source and the target tokens? It's literally just for the target tokens. Okay. So we now understand each of the components here. Let's go and add the previous output tokens. And I think that's pretty much it. We now skip over all of this and we just retrieve back the batch. That was the collation process. So let me see whether I understand all of these components. I do. Let's just exit from the collation part, exit here, and continue here, and then we just assign that to the dummy batch, and that's it. So that was the whole process. I think the documents reflect that fairly nicely. Going to open NLLB again, going to data loading document. Let's see. We've stopped here, and I said I want to analyze how this works. And we can also add a section on explaining the collation. Let me just add it as a to-do. So open this up, go to step 7, actually end of step 6. I'm gonna add a to-do here. Explain briefly how the collation process works. Quick question from Manav. Do I publish research papers? You mean research paper for this work or in general? I've never focused too much on that, so that was never part of my work to focus on papers. I'm just doing my own things, honestly. No, in general, like I'm just not trying to play that game, honestly. Are papers important for DeepMind entry? They're not, obviously, because I've been there and I didn't have papers. Let me see, to do. Explain briefly how the collation process works. During the reset dummy batch, we call the first batch. So the first batch triggered the collation. First batch function triggers the collation procedure for the dummy batch. We iterate the process. Looks like the following. It's going to be like step 6.1. Step 6.1, note on collation. First batch function triggers the collation procedure for the dummy batch. The process looks like the following. We iterate through the indices of the first batch as determined by the output of dataset batch by size. Function call for each of those indices. We index into sampled multi-dataset, which internally delegates that index to the right language pair dataset. Language pair dataset. Which then further delegates that call to the underlying source target mmap datasets. From there, we fetch the raw tokens. We then prepend the language token in prepend, what's the name of this one? Prepend token dataset. And finally, we propagate sampled multi-dataset propagates that information upward in a form of a dictionary with 3 keys: ID, source, target. Datasets collate function subsequently extracts the source tensors from each of those sample dictionaries and finds the max sequence length and creates a tensor of dimension source length times max source length, or source batch size. Okay, then it fills it in with source tokens, applying left padding. Similar thing happens for the target tokens, with the only difference that we do right padding. So we do right padding there. Finally, we create another tensor that is the copy of the target tensor, with the only difference that the EOS token is rotated so that it's now the first token in those sequences. Effectively, they are using EOS token as a BOS token as well, i.e. start/beginning of sequence token. Okay, and once that's done, it retrieves back a dictionary with source, target, and that special one tensors, plus some additional metadata like number of tokens and number of sentences, etc. And this is what you actually end up seeing if you look at our data loading for loop for either training or validation. This is just my raw thoughts. I'm going to refine this, but just wanted to dump it there. I'm going to refine that very soon. If you want to implement something from scratch, like transformer models, etc., what steps do you perform, like make notes or other things? I don't know. It depends on how much you know. It depends on whether you want to start from scratch completely, or which you usually don't do, or there's a ton of open questions here. I think Discord might be better place to ask those questions than here on the stream, which is mostly related to this open NLLB project. You'll get stuck in dimension errors, like general dimension error. I'm not sure what your last question is referring to, honestly. Note on collation. This is fairly detailed description of how everything works. I'm very proud of this document, honestly. Shapes errors. We all get stuck in all of the most obvious errors that everybody in deep learning faces. There is always a ton of problems. That's all just natural, very much natural. If you take a look at this stream or some of the previous streams where I was debugging weights and biases, there is always a ton of problems and silly issues. Okay, let me refine this section on collation. So first batch function, triggers the collation procedure for the dummy batch. The process looks like the following. Function mentioned above. Called as a part of reset dummy batch. Triggers the collation procedure for the dummy batch. Which is effectively the first time that our code calls into the data pipeline with .e. The process looks like the following. We iterate through the indices of the first batch. Okay. For each of those indices, we index into the sample multi-dataset, which internally delegates that index to the right language pair dataset, which then further delegates that call to the underlying source target mmap dataset. From there, we fetch the raw tokens, the quote-unquote raw tokens. From there, we fetch the raw tokens, which are then prepended with the language token. And finally, sampled multi-dataset propagates this information upward. Is this even a word, upward? I think it is. Upward. There's a fireplace, upward, in the form of a dictionary with 3 keys. Okay. Next up, sampled multi-datasets collate function subsequently extracts the source tensors. Function delegates this call to collate function. Subsequently extracts the source tensors from each of those sample dictionary, from each of those sample dictionaries. Next up, this collate function is triggered, and internally it delegates this call further to language pairs datasets collate function. The collate function extracts the source target tensors from each of those sample dictionaries, finds the max sequence length, and creates a tensor of dimension batch size, number of samples, I guess, max source slash source target length. The collate function extracts the tensors from each of those sample dictionaries, finds the max sequence length, and creates a tensor of dimension like this. initialized with a padding token, with a pad token. Initialized with a pad token, or initialized with pad tokens. Okay. That resulting tensor is then populated with source/target tokens, applying left/right padding respectively. Finally, we create another tensor that is the exact copy of the target tensor, with the only difference that the EOS quote-unquote token is rotated so that is swapped so that it's now the first token in those sequences. Effectively, they're using EOS token as a BOS token as well, a start beginning of sequence token. The collate function finally returns a dictionary. Let me just now open up the program there and just see how this was exactly looking like. Collate, here it is. So we had this previous output tokens. Okay. Previous output token, that is exact copy, blah, blah, blah. Okay. The collate function finally returns a dictionary that looks like this. Looks like this. So source tokens, length, target, and there is also the previous output token, which is going to be here. Let me just double check that. So this is actually added to the net input, previous output tokens. Okay. Not sure why it's called like that. Let me just think for a second. So target. Why is it called previous output tokens? That's effectively target. I'm not sure why we are using target for. Because we want to pass this beginning of sequence and then the tokens, and then we pass that into the decoder to compute the loss. So I'm fairly sure we're actually using that as the target. Well, actually I'm lying. The target is going to be, yeah. That's the input. And then the target is the actual thing we're comparing against, because it ends with a, yeah, makes sense. Previous output tokens. Okay. Now I understand. Another tensor that is exact copy of the target tensor, with the only difference that is swapped so that it's now the first token in those sequences. This is the tensor that we feed into the decoder, and we compare its outputs against the target tensor. Okay, so this is it. This is all we retrieve back, and this is exactly what you end up seeing if you take a look at our data loading loops for either training or validation. Now you understand exactly how the whole process works in the background. Almost. See the next couple of steps. Okay, let me see how this looks like. Looking good. Hopefully this will be useful to people. Let me quickly submit this. Let's just navigate to PearSec. I mean open NLLB. Change directory. Okay. That's it. Push the changes. Let's just wrap up the last couple of steps. So step 7. This one is called here. Here in the beginning of the training loop. And then subsequently it gets called, wait, validate, intermediate, train. So it gets called here, and then we have a ton of train steps with the same iterator. And then at the end of the epoch, what do we do? Let me just see again, train. We call get train iterator again at the end of the epoch, which goes through the same pipeline, but this one is called here. And is there any other call to it? Language modeling, generate, we don't care about those. Train, validate, test, test. So it's called inside of the train on 3 locations. Here and here inside of validate. Okay. Okay, so let's go back here. Function. Okay. Let me just double check again. We called it on the get valid iterator, which retrieves back the iterator. And then we call on top of that. Okay, got it. So step 7. Once we have retrieved the epoch batch iterator from step 6, we call the next epoch iterator function on it, and it does the following steps. It shuffles the frozen batches and additionally does the indices sharding. Okay. And then second, shards the indices across different GPUs on our system by wrapping the shuffle batch into sharded iterator. Okay, so then I'm just asking myself, we sorted frozen batches so that we start with shortest, so we start with shortest batches first. So the first batches are gonna have like a large number of sentences that are fairly short. So then, doesn't it be to purpose to just do this shuffling afterwards? Let me think. Well, it doesn't, because all of those batches are gonna be, the important thing is that we minimize the padding amount. It shuffles the frozen batch. So let's just quickly go to the logic. Let's just quickly go through that logic. Let's exit here. Let's just see it in practice. So let's just enter here, go all the way to here, and let's see what happens. So when we enter here, whoops, why are we still here? Just a second, we triggered the second process. Let me see where this second one is. One of them is here. Okay, I want to continue with this logic. How did we step over this already? Wait. Hit F5 here, and we are back. So enter here. Get iterator for epoch. And this guy does the shuffling of the batches, of the frozen batches, shuffles them, retrieves them back, and then we shard them. That's it. Frozen batches is arranged in such a way that all batches are, let me just think for a second here. All batches are, so the first row has the indices of very short pairs. In such a way that its first batches, its first rows contain indices of those of the shortest samples in our data set. Thus it leads to a construction of, thus those first indices lead to a construction of batches that have a large amount of short sentences. As we progress through its rows, the batches end up having less and less sentences and are longer in length. Okay. Basically going from left to right and top to bottom across its indices, we get progressively bigger samples, longer length sentence pairs. Let me see whether that makes sense. As a sentence, it shuffles the frozen batch. Frozen batch is arranged in such a way that its first rows contain indices of the shortest samples in our dataset. Thus, those first indices lead to a construction of batches that have a large amount of short sentences. As we progress through its rows, the batches end up having less and less sentences and are longer in length. The list of lists of indices is arranged in such a way that its first rows contain... Okay, this is all good. Okay. Frozen batches rows. Okay, and then shards the indices across different GPUs on our system. And this happens by basically grabbing... Let me quickly open this up. Where do we stand here? So we have sharded iterator here, which basically grabs the iterable so we are here. We shuffle the batches. Batches are passed in as an iterable. And we grab every second, okay. And then every nth row is going to be fetched onto the different device. This can lead, because of shuffling, this can lead to... They should have first sharded and then permuted. Because this can lead to potentially one GPU handling a much bigger load than the other one. Just an observation here. If you have n GPUs on your system, the first GPU will take out 0th and minus first rows from the batches. So if you have n GPUs, you will take the 0th and then okay, I think this makes sense. of the shuffled batch. Note on my side, I think it might be better to first shard and then shuffle, because doing it like this, we might end up having a much bigger load on doing like this as an edge case. In the worst case scenario, we might end up having a much larger workload on one of the GPUs, because we don't have the let me think. I'm actually lying. The number of tokens is roughly the same in all of the batches. That's how they're constructed, but they have, the shapes are disbalanced and they have different properties. I think it's preferable to run many sentences of short yeah, you want to run shorter sentences than longer one. The first shard and then shuffle, because doing it like this, in the worst case scenario, we might end up having a much larger workload on one of the GPUs. Because, for example, all of the quote unquote wide batches end up on that GPU, i.e. small batch size, long sentences. Okay, step 8. The sharded shuffle batches are then passed into PyTorch data loader together with sampled multi-dataset and its collator function. Step 9. All of the above is then wrapped into a counting iterator, which just does what the name suggests, keeps tracks of the number of consumed batches during the training validation. And finally, counting iterator object is wrapped into a progress bar, okay, let's just go to train, progress bar, JSON or weights and biases. Okay, let's just do some additional logging to the console and or weights and biases dashboard, and then delegates the call to the counting iterator. Note, only the main / master GPU will master GPU. It has a global rank equals to 0. We'll log to weights and biases. The other processes, the other GPU processes won't have that additional progress bar wrapper. That additional WhenDB progress bar wrapper. Instead, they'll only have the, for example, the JSON bar wrapper. That's it. That's pretty much how this whole thing works, guys. It's a long document. I think it was worth writing it down, also for myself when I forget these details. This is now completely clear. Okay. Let's go to train. Let's just get to this moment when we start actually sampling. Hit F5. we are here. So here's how the process now looks like. So progress is a JSON progress bar. We grab the length of the iterable, which is going to be counting iterator. That's the amount of batches it has. And then we loop here. If it has next, it delegates the call to PyTorch data loader, which is going to fetch the next piece of data, basically. Indices, collator. But then in the background, let me just think for a second. We already have these indices that we pre-computed, which are already sharded and shuffled, and it's gonna just do the same logic that we've done before in the collation. So you have the indices, you have the collation, you have the data set, you just extract for those indices, you extract those dictionaries, and you pass them to the collate function of the sampled multi-data set, and then it's gonna do its magic, extract the source and target tensors, aggregate them, put them into this tensor that's going to be left and right padded depending on the source, whether you're dealing with source or target, and you end up with this final dictionary. That's what happens behind the scenes. PyTorch data loader introduces a lot of additional complexity because of asynchronous loading and stuff, whatnot. But that's it. Let me think for a second. Yes, so we shuffled beforehand. So PyTorch data loader literally just has to go through that batch of indices. All of them map to a single output dictionary. Okay. The hard part here is it's not easy to debug PyTorch data loader because there are some timing details here. Get from the data queue. So it has the data queue that is being basically populated in the background. Okay. So again, just to clarify, let's find this line. Let me close this. Let me just find this line where we call the data loader. So here, get the next iterator. Epoch batch iterator class epoch batch iterator, and then find this. Here is that function, and then we have this. So again, the data loader has batches which were sharded already, and it has the collate function. What's the offset? The offset is just, I think, set to 0 always. Why would we set offset to non-zero value? So what it's going to do is the same thing as what we've seen for the dummy batch preparation. It's going to take row by row from this batches object, and those rows contain the indices, and then it's just going to index using those indices into the sampled multi, which is going to source these dictionaries with ID, source, and target keys that contain the data, and then the collate function is just going to make this final object from that. So that's it. So now just let's see let's just understand this offset, whether that's going to do anything. Let's go here. Do we ever pass the offset to this one? Epoch shuffle fix. I don't think we do. Epoch shuffle fix. Offset is always 0. This one is not used. So we just use the whole thing. And number of workers. Number of workers is set to what? It depends on the self. Number of workers here. It depends on how we construct the batch iterator, I guess. We set number of workers is default 0. But when we construct it, I think we pass in 1 or something. We pass in 1, if I recall correctly here. So when we are making it, we are passing number of workers, dataset, whatever the value was in the dataset number of workers. Which is what? Let's just see. Let's wait for this to finish. I think we're running in the background. Almost done. Let's just stop this and run again. Just see config dataset number of workers. What's the value we use there? So every GPU will basically have its own data loader, which is dealing with its own shard of the data. Config dataset number of workers set to 1. Yes. Okay. Let us push this out. Okay. Final data pipeline document. Let's just push this out. And we can now go on to the next task. After I just share this with people in the Discord server, let's see how it looks like. Here it is. Okay, my system is starting to glitch again. I don't like this. I think might be some rendering cache or some streaming cache going on with OBS. Share this with the good people of Discord. Check this out. Detailed description behind the whole data loading logic. Feel free to submit a PR if there are any errors, typos. Okay. Let's close this down. And let me see whether I've stopped the run. I did. I did not. That's why it's maybe slower. Okay. So here are the to-dos. Write the document. Next up is let's add these tasks to GitHub project, and let me also add Raquel as a collaborator. Just a second, guys. Okay. So, time to populate this project's set of tasks. Let me again go here. Add more tasks to the GitHub project. Understand how to avoid Hydra error. Okay, those are some of the next steps there. There was one more thing I wanted to do though with the dumped pickle file I made. Do I want to put that as a part of a task here? I think it's too much of a my personal understanding task than something that people should pick up themselves. It's 2:25. Let's first wrap up the tasks here, and then I'm gonna focus on that one. Okay. Reduce peak memory when using FSTP on 2 GPUs or even more. How can somebody contribute to this? I want to add raffle here. Let's see how we do that here. Assignees. Whom can I assign here? Search people. Suggestions, only myself there. Workflow settings, what's new? Maybe settings. Might contain something. Project settings, readme. I thought I already wrote down something here. Manage access. I think, yeah, this is public. That's fine. Manage access. Invite collaborators. Public and visible to anyone. That's fine. So I need to invite someone. So let me just see. I'll have to do this in a DM, so I don't disclose Raphael's email address. Let me just quickly see this. I just need his email address. Maybe already kept his address. Let me just see in my inbox. Raphael. Okay, I actually found his address. Okay. Invite. With the role of writing. Why is this not working? I'm trying to invite somebody. I'm pressing here, but nothing is happening. Does that mean I already have to invite somebody to a project itself? Invite someone to GitHub project. Not to the repo, but... Well, I guess I have to first go to this project and then go to settings there, I guess. Collaborators. Invite people. Okay, so I guess while we are waiting for that to happen, I'm just going to add that myself. Go to the projects. Reduce peak memory. I think I'm going to just edit this and just add 2 plus GPUs, I guess. Okay, this automatically refreshed here. Let's see what are some of the next tasks I wanted to add. Okay, let's create an issue on the project. Oh, okay, I see that Rafael has been creating some of the pickle issue and stuff. What's this? Figure out the pickle issue mentioned here. Current workaround. Okay, so that's the actual pickle issue that I've mentioned. That happens in the multi-generate script. Config file might be worth mentioning. Okay, he just linked my bug. Makes sense. Hydra pickle issue in generate multi-by. Let's add this one to here. How do we add a new task? Control space or whoops, what happened there? Delete from project. This one should be added here. And then let's take a look here. So this is a to-do. Nobody's tackling this yet. And then sub batches creation. What is this? Understand which optimizations are done in Fairsec under the hood. Sub batches creation with respect to source target length. Explore Fairsec code base in this matter. This is actually answered already, which is basically my doc. Again, this one. I think this explains your question. I think that this document is a reply to this question. If not, if so, close the issue. I'm just going to comment and let's see what else. So this is a bug true. This is potentially a bug also. Let me see, do I want to multi-label this? I want to add maybe question and a bug in a way. Let me see what else, a question and a bug. Help wanted, lol. Okay. Spanish and Guarani filtering. See what this one is about. Small tip, always be precise about the data source. In this example, this was only related to the public bytext, and the answer was already provided. I know that our Discord channel is a bit overwhelming because of me. Okay, this one is closed. Native language visualizations. Go through the files for your native language and see whether there are any issues. Additionally, feel free to do whatever type of analysis you see fit. Embedding, blah, blah, blah. See if there's anything wrong in the data. Okay, this is more of an open-ended type of a task. This is like good first issue. It's not a bug. Yeah, I think this is a good first issue. Do we want to actually put this here? I don't want to put all of these here. I want to just put mission critical ones here, and that's one of them. And Hydra is also slowing us down from doing the generations. So I'm just going to leave this one as it is. I'm going to edit this just to give a bit more context to people how they can get started with this. Files for your native language and see whether there are any issues. Check out the getting started document here. For how to download public bytext for your language. Submit share, for example, weights and biases report as the final result of your work. We'll keep track of these for all covered languages. Okay. Let's go. generate multi. Wait. Generate multi. Okay, that's the name of the script. And so this is indeed a workaround. Let me just see whether it's the same as what he has. Hydra launcher, and then create a module. This is actually the workaround. Okay. LID model peak probabilities. This is more of a research type of a task. Let me think what's the best way to handle these. These are more open-ended. I don't think we need to do this one. Choosing the LID model. Where did we use this one? Okay. I think these are the two ones currently that I'm struggling with. If these were fixed, I could run a bigger batch size, and then I just need data. So I'm just gonna put that as an issue as well here. It's not bug, it's documentation. Feature request. High quality Serbian parallel corpus. Currently, zero support in our public bytext for HPS. Copy that to contribute to find high quality quantity by text data. This is between a couple of bilingual checkpoints before we kick off bigger runs. Okay. And then this is in progress. Okay. Download a subset of mine data and analyze it. Push it through as well. Mine data from Alan AI's using Alan AI's dataset replication. So far, we've been only dealing with public bytext. And we haven't set up the pipeline for downloading and processing mined data. Alan AI, NLLB, I think it's this one. Let's just add this one. Okay, so data and compute, distributed compute. Those are the main issues there, I see. I think this is enough for start. We'll be adding more. These are the main ones. There's also curriculum learning. I'm actually lying. There's a couple more tasks we need to add. Understand how to do 4-stage curriculum learning on the paper. Not quite clear. How do we set up a 4-stage curriculum learning? Looking through the code base. Understanding this will be super important once we start running on a bigger number of languages. There is some mention of it in this README. Write a report and share the learnings of how to do this. Note, we could always do this manually by stopping and restarting for different jobs. Error prone, and I suspect Meta had a more streamlined approach. Curriculum learning B. GitHub. Okay, GitHub NLLB. Curriculum, okay, training or modeling. I think that was the name. Modeling section, and then curriculum learning. Training with curriculum is mentioned here. It's not quite clear how do we set up for stage curriculum learning. Training, looking. Training this will be super important once we start running on a bigger number of languages. There is some mention of it in this README. Write a report and share the learnings on how to do this. Okay, this is help wanted. Not a good first issue. It's kind of the documentation, maybe even. Okay. That's it. And then let me just see, by the way, is anybody writing anything? No, I don't see anything. Okay, so curriculum learning was one thing. And then we need to compute. We need the number of GPUs and estimate compute hours for the project. Okay. So there is one more thing I want to add. No, help is not wanted here. Let's remove this one. And this is more of enhancement. I'm going to remove question here. Let's not bloat it too much. This is more of a documentation. And then okay. Looking good. Let's submit one more issue. Question, what should this be? I mean, these templates are all the same because I just delete the template either way, but let me think, what do I want? Compute requirements for the project and number of GPUs. That's gonna be like documentation or something. Estimate the necessary compute and number of GPUs for open NLLB effort. Our goal, our first big milestone is to open source a 3.3 billion NLLB checkpoint. Estimate the necessary compute and hardware to train this in reasonable time. Definitely not a good first issue. Okay. Let's go here. And let me just add this here. Okay. Looking good. Just some organizational stuff today, guys. Anything else I wanna add right now? I don't think so. Okay. let's see, what's going to be the first next model we're going to train? So I want to train, for example, just to build up some muscles here, a very good, for example, English-Serbian bilingual model. And then in parallel, we have to start getting some compute grants. Otherwise, we can't really train these big models on on this hardware. So how can we link? Let me link the issue. This is not a question. This is kind of in progress. I started analyzing exactly this, but I did not get to the final of it. I didn't complete it. I'm gonna put myself as a placeholder there. Okay. Looking good. Can we move these around? Yes, we can. Let me put the higher priority items up there. Compute and corpus. Something like this. Okay, guys. That's it for this stream. I'm gonna make a lunch break now, and then after the lunch break, I'm gonna do a couple more tasks. One of them is to analyze this thumbed pickle file that we have to just understand exactly the way that this batching and sorting by size works. And then I'll have to probably spend some time analyzing some of these Serbian corpora. So that's going to be the tasks for the next stream. What kind of text corpus would be ideal for this model? Does it require any form of human annotation? No, you just need, I mean, implicitly yes, because you need a parallel corpus. This is a machine translation system. You want to have, for example, a sentence in English, and then on the same line in a different file you want to have a sentence in Serbian, and you need such paired data sets for each of the language directions you want to support. That's the gist of it. Thanks for the question. If you want to learn more, join our server here, open NLLB channel. That's the best place to get familiar with the project and get started. There are pin docs here. You can find everything you need right here. Okay, guys. See you in the next stream in roughly 30 minutes. Cheers.